United States people. Hey, so we are continuing our little talks. See what I did there? See what I did there? On calculus, and specifically part 2 of differentiation from first principles. So here we go. We need to talk about alternative notation. If we have a function f of x, f prime of x represents the derivative function. If we are given y in terms of x, then y prime, or dy dx, this is commonly used to ask for the derivative, and this is telling you how it's read, dy dx. It is not a fraction. What it means is the derivative of the function y with respect to x. So those are the two most common notations, f prime of x, dy dx. Actually, there's 3. And if the function is given in terms of y, sometimes you'll see y prime. All of those stand for the derivative. And then this little drawing, which we talked about last time, if we replace the h right here, remember there was an h here, if we replace it with the lowercase Greek letter delta, then we talk about delta x. That is the distance between the x and the x plus h, or x plus delta x. That becomes quite important later. Instead of the h approaching 0, we have the delta x approaching 0. Okay, got that out of the way. Okay, so the derivative when x is equal to a. Now in the past example, I think we did x is equal to 3, and we moved the graph around a bit, but we found the derivative when x is equal to a particular value. So the gradient of the tangent, the slope of the tangent to y equals f of x, the curve, the slope of the tangent to the curve at the point where x equals a is denoted f prime of a, where f prime of a equals the limit as h approaches 0 of f of a plus h minus f of a over h. All that has changed from this is instead of x, we know what the value of x is. That value is a particular value a. And still h is approaching 0. Okay? Big lesson here. The derivative gives you the slope, which is a value, of the tangent to the curve. Say it with me. The derivative is slope of the tangent to the curve. Slope of the tangent to the curve. Slope of the tangent to the curve. You got to remember that slope is a value. If I say, what's the derivative? You're going to say, slope of the tangent to the curve. Slope of the tangent to the curve. That's what you're going to say with me. Okay? And we will do one final example here. Okay? Let's see if this is going to work. Oh, there it is. Good. We have our definition. Okay? Oh, actually, I don't want that. I want to get rid of that. Sorry, bear with me. I want this. Computer's being really slow today. I apologize. Okay, I'm going to put this here. It's sort of in the way, but I don't care. All right. Use the first principles formula. Oh my gosh, it's right there. I went through all that trouble and I don't even need it. Use the first principles formula. F prime of a equals the limit as h approaches 0, blah, 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 to find the instantaneous rate of change. That's what the derivative gives us. The instantaneous rate of change, which is the slope of the tangent to the curve in this function at the point where x equals 5. So the first thing that we have to do is use this. So f prime of x, okay, is equal to the limit as h approaches 0. And I'm going to use x first, and then when I'm done, I'm going to replace x with its correct value of 5. You got to do the algebra first, okay? F of a plus h, okay? So my function, my f of x is x squared plus 2x. Basic rules of function. If I'm taking the function of a plus h, wherever I see x, I'm replacing it with a plus h. Okay? But in this case, my a is equal to 5. So I am going to change this to f prime of 5. So this becomes, remember, I'm going to have 5 plus h. Okay? So this will be 5 plus h squared plus 2 times 5 plus h. Now I have taken care of this right here. All I've done is taken care of this part of the formula. Minus f of 5. Well, what is f of 5? F of 5 is 5 squared, 25, plus 2 times 5 is 10. So that's 35. All over h. So we have to do some algebra here because we have something undefined. So this becomes the limit as h approaches 0. So this would be 25 plus 10h plus h squared plus 2 times 5 is 10 plus 2h, oops, minus 35, forgive me, I ran out of room, all over h. And let's clean that up. That equals the limit as h approaches 0 of, let's see, 25 minus 35 is negative 10, plus 10 is 0. So I end up with 10h plus 2h. So all these go away. 25 plus 10 is 35, minus 35 is 0. So I end up with h squared plus 12h over h. Oh, you see what's going to happen? I'm going to be able to factor out an h in that numerator. So the limit as h approaches 0 of h times h plus 12 over h, kapow, with direct substitution, this is equal to 0 plus 12, which is equal to 12. So what we're saying is that the derivative of the function x squared plus 2x when x is equal to 5 is equal to 12. That means the slope of the tangent to this curve when x equals 5 is equal to 12. Don't believe me? Let's take a look, boys and girls, because I got it set up for you right here. Okay? So I have the function x squared plus 2x. I have plotted the point 5 and at 35. I have constructed the tangent to the curve at that point. So now we just have to measure the slope. And back here, we said that slope is equal to 12. Let's see how well we did. So I'm going to go Menu, Measurement, Slope. Are you ready for this? I'm going to select the line. It's finding the slope of that line. I'm moving it. Kapow! It is 12. The slope of the tangent to the curve x squared plus 2x when x equals 5 is 12. The slope of this line is 12. That is the derivative. It's the instantaneous rate of change. It is freaking beautiful. Hope you enjoyed it. I am out!